Welcome to the Mongabay newscast. It's April 8th, 2021, and I'm your host, Mike Gurecki, bringing you the news and inspiration from nature's front line. Today we're discussing planetary boundaries, 9 environmental systems identified by scientists as essential to Earth's ability to sustain life, and the limits to how far out of equilibrium we can push those systems before facing large-scale, irreversible environmental changes to our planet. Global climate change is one of the 9 planetary boundaries, and probably the best known. Scientists believe we have already transgressed the safe operating space for Earth's climate, and are rapidly approaching thresholds beyond which human society as we know it, and all life on Earth, will be at considerable risk. Every life form on Earth depends on a shared set of environmental resources, known as the global commons, which make up the life support systems providing us with a habitable planet. These life support systems have been in relative balance for the past 10,000 years, giving rise to the biosphere that has allowed human society to grow and flourish. But over the past century, our exponentially increasing resource consumption and pollution have destabilized these natural systems. Mongabay has launched a special reporting project called Covering the Commons that uses the planetary boundaries concept to look at how Earth's natural systems support the global commons and the ways in which human activities are pushing us toward dangerous tipping points. We welcome to the program today 2 journalists who have recently filed stories under the Covering the Commons reporting project. Claire Asher, a freelance science communicator and author, joins us to discuss a recent article she wrote for Mongabay that breaks down what the 9 planetary boundaries are, the 4 boundaries we're already exceeding, and the opportunities we'll have in 2021 to transform the way we live on this planet and restore equilibrium to Earth's vital ecological systems. We also speak with Mongabay contributor Andrew Willner, who helps us dig into solutions to our environmental transgressions by telling us about his recent article on the new age of sail that would transform the global shipping industry, a major source of the greenhouse gas emissions that are driving global warming. Willner tells us about the cutting-edge technologies that are being deployed on ships right now to decrease their fuel consumption, including a number of modern types of sails that are once again harnessing the wind to power the ships moving our goods around the world.
I want younger people to understand that there are solutions, that the world is going to be a tough place in mid-century. But if we work on solution-based things, we can make the landing a little bit softer for our children and grandchildren.
The concept of planetary boundaries was invented by an interdisciplinary team of scientists who set out to define the limits of a safe operating space for humanity on Earth. According to our first guest today, Dr. Claire Asher, the scientists asked themselves, what are the boundaries of the environmental systems of our planet within which we can safely operate, and what changes can we force on those systems before we trigger rapid, catastrophic environmental harm? Here's Asher with more background on the planetary boundaries concept.
The planetary boundaries idea, I think, started in the early 2000s, and it was kind of spearheaded by a scientist called Johan Rockström, who is the founding director of Sweden's Stockholm Resilience Centre. And I think when I interviewed him for the article, he explained it to me that the idea kind of sprouted from 3 pillars of scientific evidence that have been developing over the last now 40 or 50 years. So the first of those is the idea that the Earth is a complex self-regulating system. So, the oceans, the atmosphere, the soil, the living biosphere all interact in a really complicated way, and together they create the kind of conditions on Earth that we experience. And then the second idea is that tipping points exist within this system, so that there are kind of these irreversible thresholds which, if passed, set off their own feedback loops and their own kind of cycles, which can change the system, this self-regulating Earth system, into a different state. And an example of that I think people are probably somewhat familiar with is the idea of the Greenland and Antarctic ice sheets, and this idea that as they melt, they warm the Earth further and then create more climate change, which melts them faster. And so you see this acceleration. So that's the idea of tipping points. And then the final piece of the puzzle really is the kind of relatively recent discovery that we have entered a new epoch in the geological history. There's quite a lot of evidence that through our own civilizations, we've now influenced the planet so much that you can actually see that in the record of geology. You can see the increased carbon dioxide emissions into the atmosphere. You can see the impact of deforestation. And so that has caused geologists to say, okay, well, we've actually now entered an entirely new geological epoch. The Anthropocene is what this new epoch is called. And before the Anthropocene, we were living in the Holocene, which was a period of really remarkable stability in Earth's history. So for about the last 12,000 years, temperatures have only varied by like about 1 degree above or below the kind of the average for that period. And if you look further back in Earth's history, that's really quite unusual. You know, things have been a lot more tumultuous in the past. And the Holocene came out of 100,000 years of glacial and interglacial fluctuation. So these really big changes in climate. And then we came into the Holocene and it was, things have been really, really stable. And it's in those 12,000 years of the Holocene that you see humanity's civilizations flourish. So modern humans have been around for about 200,000 years. But it's only in the last 10,000 years, so only within the Holocene epoch, that we've developed, I mean, literally everything that you see around you, every aspect of our society that we think of. You know, we've developed agriculture, industry, urbanization. Humanity has flourished. And it seems likely that stability has really been a big factor in allowing that to happen. So realizing that we've now, through our own actions as a species, have started to enter this new epoch, the Anthropocene, is really a warning call that we're starting to push up against the limits of what the kind of the coping capacity of the planet is. And so Rockstrom kind of saw all of this science coming together and thought, okay, we need to understand what the safe operating space is for humans to live in, right? Or what conditions do our societies need in order to keep functioning? And it might be that there are climates, possible Earth climates, where human civilizations as we know them are just not possible. So he wanted to define the safe operating space for human civilizations. And he got together a huge international, interdisciplinary team of all the top scientists in their respective fields. And they set out to define the key Earth system processes, the key aspects of that self-regulating system that we are influencing and that could potentially push us into a new climatic state.
And so those are the 9 planetary boundaries.
Exactly, yeah. So climate change, biodiversity integrity, ocean acidification, depletion of the ozone layer, atmospheric aerosol pollution, biogeochemical flows of nitrogen and phosphorus, freshwater use, land system change, and release of novel chemicals.
And they found that we've already exceeded 4 of those boundaries, right?
Yeah, so they did the initial report in 2009 and then updated it again in 2015, and they found that for at least 4 of the 9, we're already outside that safe operating space. So for climate change, biodiversity, land system change, and nitrogen and phosphorus, we're already outside. We're already in the danger zone, basically. And we don't know exactly how much further we can push those systems before they collapse.
I think most everyone is familiar with climate change, of course, but would you say a bit about the other 3 boundaries we've exceeded, just so everyone is clear what we're talking about here?
Yeah, so climate change is the one we're all very familiar with. Biodiversity is fairly self-explanatory. That just includes all of the ecosystems and the ecosystem services that they provide. So things like clean water and food. Land system change is about how humans are changing the land. So a really good example of land system change is deforestation. But any time that humans alter from a natural ecosystem to some other land use, whether that's agriculture or industry or, urban areas, that's land system change. And then the last one, biogeochemical flows. So that refers to these key nutrients, nitrogen and phosphorus, which are really essential for plant growth. And they exist in these complex cycles where they move between the soil and the plants and the atmosphere. But we're really altering them a lot by mainly through agricultural fertilizers. So we put a lot of nitrogen and a lot of phosphorus onto the soil to help grow our crops better. But that also runs off into nearby rivers. It's emitted into the atmosphere. And so we're really changing those natural cycles of nitrogen and phosphorus quite a bit.
What does it actually mean for us to be currently transgressing these environmental boundaries? How long can we live beyond these boundaries before we induce the worst impacts or we irreversibly change Earth's ecosystems?
Yeah, that is the $1 million question. Nobody nobody really knows for sure, because there are so many interactions between these different boundaries and between these different processes that they can interact with each other in ways that is really difficult to predict. And scientists have obviously been studying this in a lot of depth, but there's still a lot of unknowns. So what Rockstrom did was to set out kind of two boundary levels. So the first boundary level would be, leaving the safe zone. And then the second is the actual kind of the tipping point, the threshold that beyond which we have no control to change things back again. And then so between those 2 points, there's this kind of this danger zone, the zone of uncertainty, where we don't know. We just really don't know how long we can push these things or how much we can push them before there is a point of no return. And so, yeah, that's quite terrifying, really.
I liked how you put it in your article. You likened it to humanity being blindfolded and walking towards 9 cliff edges.
Exactly, yeah. And we don't know where those cliff edges are, or whether there's going to be a strong wind blowing behind us to push us to them faster.
So I wanted to talk a little bit about what scientists are saying we need to do to address these issues. You write in your piece that 2021 offers 3 chances for us to avoid planetary boundary overshoot via 3 international meetings: the Convention on Biological Diversity meeting in Kunming, China, the UN Climate Summit, or COP26 in Glasgow, UK, and the UN Food Systems Summit in Rome. What kinds of agreements do scientists say need to come out of those meetings?
The view of the Earth as this complex self-regulating system kind of leads to the conclusion that we need really holistic approaches. So it's very easy at the moment to focus, on one aspect. So people will work on conserving biodiversity, or people will work on climate change, and we need a far more holistic, all-encompassing approach that takes into account all of these different things and the way that they interact. And I think science is very siloed into little disciplines in exactly the same way that then policy quite often is siloed into these specific areas. Some of the people I interviewed talking about moving to this view of Earth as a global commons, like a shared resource, and humans as stewards of that, and trying to come up with much more global solutions that integrate all these different aspects together. And I think that these 3 meetings are a really good opportunity for that. They bring the whole world together, and it is an opportunity to set targets that take into account the different interactions that we're aware of, at least. And really think about how we can restructure our societies to fit within these planetary boundaries. So one really key area, I think, is food systems, the way we produce food. So food production accounts for nearly 25% of greenhouse gas emissions. It's also the biggest driver of biodiversity loss, biggest cause of land use change. And as I said, it releases a huge amount of nitrogen and phosphorus pollution, and demands a lot of fresh water. So it touches on sort of maybe 5 out of the 9 planetary boundaries. And so I think focusing on how we can reform food systems to fit better within the planetary boundaries at a global scale would be a very good start.
You actually co-authored a book with Chris Foreman, a researcher and physicist at Northwestern University, called Brave Green World, which discusses the planetary boundaries and how different scientific disciplines can come together to provide some solutions. Tell us a little bit about the book and how planetary boundaries come into it, and the highlights of the joint discipline solutions you write about.
Brave Green World, my book, it starts with the foundation of the planetary boundaries as a restraint on our society. So, it says, right, we've got a certain amount of energy input into the Earth, we have, a certain amount of resources, and we need to make sure that we target our scientific research so that we can, develop new technologies and new ways of manufacturing and so on, which allow us to live within those restraints, because we can't change those restraints, And so, yeah, it really rests on the planetary boundaries framework initially, and then it asks, how can we address this? We come up with some solutions that kind of potentially bring together a lot of really different disciplines. So we talk a bit about genetics, about synthetic biology, ecosystem science, artificial intelligence, 3D printing, and then my co-author's speciality, which is chemical computing, where you actually make matter compute for you. And so we kind of imagine this possible future world where all these technologies come together and operate almost like an ecosystem, so that you can have different industries exchanging waste products and reusing them and passing them between each other in the same way that, you know, nutrients pass between plants and animals in an ecosystem. And ultimately, we imagine that all of this could come together to create what people call a circular economy. So where nothing is wasted and where everything is not even, I mean, recycled, yes, but at the level where things are designed to be recycled, are designed to have a new use, and where the building blocks of those are kind of interchangeable in a way that we don't have right now. And there's some examples of things that are already kind of starting to happen like that. So there's the Kalundborg Eco-Industrial Park.
Kalundborg Eco-Industrial Park is an industrial symbiosis network located in Kalundborg, Denmark.
Which I think is amazing. And they have multiple different industries all working together there, and they exchange all sorts of different things. So, for example, the waste can be passed from one industry to another. And that park has very, very low impact on the environment around it, because it just passes everything internally within that park. And so we envisage a world where we could do that on a global scale, to have a view of the future where we can live within the planetary boundaries, and we don't have to give up, technological innovation, or having, we don't have to give up the nice things to have a planet that is habitable. But we do need to invest now in science that is going to underpin that, and getting these different disciplines to work together and to think about what future they're building.
So what's needed is really holistic, transformative change across pretty much every sphere of human endeavor, which seems like an incredibly monumental task, but you cite in your article an example of the world coming together in the way we need to do around climate change and biodiversity loss, etc. And that example is how we dealt with ozone depletion.
Yeah, definitely. I mean, I think that is the one kind of the hopeful example that I hope we can kind of replicate. So in the 1980s, there started to be evidence that there was a hole or a thinning of the ozone layer, which was a result of the release of chemicals called CFCs, which were being used mostly in refrigerators and aerosol cans, and they were being used all over the world. And it was amazing, really. The scientists presented the evidence, and by 1987, the world's nations had signed the Montreal Protocol, had started phasing out CFC use, and the ozone layer has started to recover. And they're now predicting that it could be healed by 2050 completely. So, I mean, for me, looking at the way the world is now and looking back at that example, it's amazing to me that the world did manage to kind of come together and see sense and take decisive action at a point in time when it could make meaningful impact. And I think, there is still time for us to change the course that we're on and to alter our trajectory away from this, catastrophic environmental change. But we really need to be decisive. And I think it's very easy to keep having meetings and setting targets and missing those targets and then having more meetings. So I think, it's really important that these meetings actually have substantial outputs and that people stick to the commitments they make. But it is possible. We've done it before. We can do it again.
Indeed, there are signs that change is afoot in some of the most polluting industries on the planet. Take shipping, for example. It's estimated that the international shipping industry carries about 90% of world trade, and if it was its own country, it would be the 6th largest greenhouse gas emitter in the world. But change is coming, according to Mongabay contributor Andrew Willner, who has been involved with sailing and sail freight for decades. He's a former boat builder, woodworker, and sailing vessel master, as well as a retired New York, New Jersey baykeeper and one of the founders of the Waterkeeper Alliance, an international water quality organization. He's currently executive director of the Center for Post-Carbon Logistics, an organization that researches and assists in implementation of post-carbon maritime technologies. In his article for Mongabay, New Age of Sail looks to slash massive maritime carbon emissions. He writes that wind, solar electric, and hydrogen-powered ships are offering low or no carbon alternatives to fossil fuel-powered cargo vessels, with wind in particular about to make a huge comeback in shipping. Willner starts the article off by talking about the symbolic voyage of a wooden sailing vessel called the Tres Hombres.
Tres Hombres was the idea of 3 Dutch friends. They found this old barkentine, a sailing ship without an engine, and they knew they wanted to restore it to carry cargo. At first they thought perhaps in the North Sea because that was their local waters. And when the earthquake happened in Haiti,
a magnitude 7 earthquake hit Haiti on January 12, 2010, killing 300,000 people and leaving 1.5 million more homeless.
They just felt it was their obligation because they had a vessel that could make the trip across the Atlantic to load on relief supplies of various kinds. And it turns out when they got to Port-au-Prince, they were one of the few vessels that could actually reach one of the piers because of the damage that occurred in the port. So not only was it an interesting adventure for the crew, but it was also some of the first relief materials that got in by sea. And they made other voyages to the Caribbean, and on their way back, they realized that they should take something as cargo back to the Netherlands, and they stopped and learned more about coffee and cocoa, and eventually found a fair trade coffee cargo and brought it back to the Netherlands, and they've been doing similar things ever since.
And the Tres Hombres runs on sails, wind turbines, and recycled vegetable oil?
Well, although other people were doing this kind of sail freight, particularly the sailing vessel Kwai in the Pacific, this was the first transatlantic voyage made under sail that went from Northern Europe to the Caribbean probably in 50 years. And it was both an extraordinary symbol of what was possible, but also a very practical way of showing that sailing cargo is a technology that is both dependable and provable. The ship itself was pretty old. I think it was 70 years old. It probably had another life previously, but the three people involved, the partners, the Tres Hombres, decided that they would put their money where their mouth was and rebuild the ship for this new purpose.
Of course, all of our transoceanic shipping used to be done by sail. Now shipping is the 6th largest source of carbon emissions on the planet. Can you give us a brief history of how this came about?
Up until the middle of the 19th century, almost 100% of cargo was shipped by sea under sail, and that is millennia old. It's by no means a new technology. People were sailing in the Mediterranean and in the Caribbean Sea thousands of years ago and carrying cargo from place to place. It was an amazing and extraordinarily innovative technology, culminating in the large steel-hulled windjammers that operated mostly through the end of the 19th century, through the beginning of the 20th century, carrying cargoes that were not time sensitive. And there were so many of them that tea, for example, from Asia, or chemicals from Chile would be unloading every day because there were so many of these ships. They culminated in these big, extraordinarily beautiful and powerful ships that in some cases ran up through the 1940s, and in some cases beyond that, on routes that, again, weren't time sensitive, and the cargoes weren't time sensitive. But they were the high-tech version of transportation at that time. And it wasn't until steam power became ubiquitous that these very large sailing cargo vessels started to fade away. Ironically, some of their last cargoes were carrying coal to remote islands in the Pacific because the steamships couldn't carry enough coal and enough cargo at the same time to make a profit. So they had to stop at coaling stations to reload coal, and that coal was brought to those stations by sail.
Ah, the irony.
And it's sort of the similar thing is happening now. The large sailing vessels that are high-tech sailing vessels that are being built today are carrying tires and automobiles. And I thought that that's a little bit ironic, too. So at the end of the age of the large fossil-fueled cargo ships, the last cargoes are things that still emit carbon, both in their manufacture and their use.
In your article for Mongabay, you write about some new technologies. Sails are not a new technology, of course. As you mentioned, it's actually quite old. But there are some new experimental sail designs that you write about. What does this new era of sailing look like? It's not just the same kind of sails as in the 19th century, right?
Well, yes and no. I think that right now, all aspects of maritime commerce are experimenting with ways of saving fuel and also getting ready to comply with the IMO regulations that will go into effect in 2030 to cut down on carbon emissions by maritime vessels.
The International Maritime Organization, or IMO, adopted in 2018 a number of mandatory policies to reduce greenhouse gas emissions produced by international shipping.
But so some of these technologies, these new technologies we talk about, have been experimented with for years. But one of them is this, I think they're called sail kites. And what they are, it looks like a big, I guess, a sailing wing that gets released on a cable when the ship is running downwind, and it pulls the ship along, saving a lot of fuel. Another is a dyna rig, which is a sort of a much more like an airplane wing, but it's made of high-tech carbon products that are very self-supporting and don't need a lot of the rigging that some of the older ships use. And then there are things like Flettner rotors, which spin and create energy, and then there are some very high-tech ships like the Walneus ships and the Neoline ships that are using both soft sails and hard sails for propulsion. So some of these things date back to the early 20th century. The Flettner rotor, for example, and some of these wing-shaped sails have been experimented with on ships for decades before they would become into common practice. As a matter of fact, back in the 1970s, after the oil embargo, the Japanese were extremely active in experimenting with and actually building some tankers and bulk carriers that were powered by a variety of types of sails. And then when the energy prices went down again, those efforts became moot because it was much less expensive to move cargo by using fossil fuels.
So these Flettner vertical rotor sails are more like wind turbines in a way, being spun by the wind and producing energy to offset fossil fuel consumption?
As far as I know, that's how they work. I'm not an expert on Flettner rotors, but they are a mechanism by which you make power from the wind.
There's a couple other technologies you mentioned in your article, solar, electric, and hydrogen power. Are these sort of similar concepts where they're generating clean energy to reduce the amounts of fossil fuels used?
Yes. So there are solar-powered ships of various sizes. I think in probably as far back as maybe the mid-'80s, an entirely solar-powered ship circumnavigated the world. It was an experiment. And then now there are some commercial vessels that are using both solar power and plug-in batteries to move people and goods from place to place. In Scandinavia, there's a big experiment now because there's so many ferries that take passengers and freight from place to place in that highly indented coastline that they've been switching over. And there's a couple of them that just run on batteries. They don't necessarily have solar, and they plug in at each port to charge the batteries for the next trip. So that they're limited by the fact that they have to plug into shore power to recharge the batteries. But there are some others that have enough solar panels on board, and as solar panel technology improves, there are some that are actually flexible, so they can be rolled up when the cargo has to be unloaded and put aside and then put back into use when the cargo is loaded back in the ship and it's ready to go. So that can be pretty much both a self-propelled or a plug-in or some hybrid of that technology. One of the small experiments in which I was involved peripherally was the Solaris, which is a Coast Guard inspected passenger vessel that was built by and run by the Hudson River Maritime Museum in Kingston, New York. And that vessel doesn't plug in at all. It has solar panels on the top and very heavy lead acid batteries in the bilge to offset the weight on the cabin top. And it doesn't have an external plug. So it runs entirely on the power that it makes from the sun. And at night, it has about a 50 to 60 mile range on just battery power. So, as long as the sun is out, that kind of vessel can go forever. And when the sun's in hiding, then you depend on battery power to move the vessel along. And I think it's the Canadian Niagara Falls tourism company has just built a very large solar electric tour boat for visiting Niagara Falls. So there are experiments, and hydrogen can be made on board from salt water. So some of the ships are experimenting with the idea of using hydrogen directly as a fuel and making it as they go. So there's no such thing, obviously, as eternal motion, but you still have to carry some fuel on board for those times when you can't make enough to propel the vessel. So these I think are hybrids. The difference is that with the hybrid solutions, they face some of the same problems that fossil fuel vessels face. I mean, for example, this most recent incident in the Suez Canal showed how vulnerable the world is when a major artery like that gets blocked, and all of a sudden fuel prices went up. There was a food shortages started to happen, and it's a cascading effect. And so that when fossil fuels start to run out, there's going to be a race for all the rare earths and other minerals that are needed to make alternative energy products like solar panels and wind power. So I think eventually the ultimate solution is pure sailing vessels, perhaps with a small, rarely used electric or hydrogen power motors to get through places like canals or narrow passages where sails aren't efficient.
You write about how the very business model of shipping is almost becoming obsolete in this age of climate change and the need to rapidly draw down fossil fuel consumption. Is that helping usher in this new era of sailing?
Up until the late 1950s, almost every cargo was carried probably on a steamship or a fossil fuel ship, but they were very small compared to the ships that are carrying cargo now. And it wasn't until the invention of the shipping container in Port Newark, New Jersey, that allowed ships to grow and become gigantic and computerized. And that set off a very short blip, really, from the 1950s to the 2020s of the ascent of the cargo carrying container ship. And they've grown so large now, they really are their own worst enemy. Overcapacity is a problem. The fossil fuel that they use, the enormous amounts of carbon that they emit. And so whether there's an extraordinarily descent back to sailing as the primary one, or just a lot more smaller ships that are more efficient, the present model is really a dinosaur. And I think within the next 10 years, you will see some of these very large ships being scrapped. As a Korean carrier went out of business 4 or 5 years ago just because there wasn't enough cargo capacity and their ships were smaller and they weren't getting the business. So this is going to be an interesting time. I would hope to live to see some of these changes, but they will happen nonetheless. And as I said, it will go back to a very different model with more shipyards opening, with more training being done, with more longshore jobs being created, with more local goods being made and less things being transshipped from distant ports. And this whole concept of just-in-time delivery will become an antique very quickly, because that's only an artifact of these large box stores and this and these very inexpensive products made in faraway places and delivered in these giant container ships. So I think we're going to see a significant change in the carbon economy as the decade closes.
How close are we to adoption of sails and other low and no carbon shipping technologies that is widespread enough to actually make a dent in the industry's contribution to climate change?
Difficult question to ask, but I'll try to answer. It's I don't have a crystal ball. I just know that the history of shipping is such that things change rapidly when they do change. And these proof of concept vessels like Fair Transport or the schooner Apollonia or Grain de Sail, I apologize for my French, are relatively small vessels but they're proving the concept that shipping by sail coastally and internationally can work. So the model we know works. There has to be a critical mass, and that's going to come from both ends of the spectrum. All revolutions start from the grassroots up, and that's why these very small ships that are making history by showing how the process can change, and these very large ships that are designed for sailing are going to meet in the middle, I believe, and with more stringent regulations and any spike or shortage in fossil fuels will just make this revolution happen more quickly.
So, as we've been discussing, the carbon released by ocean-going ships worsens climate change, which is, of course, one of the 9 planetary boundaries we're at risk of overshooting. You write that shipping is also pushing us toward the planetary boundaries of ocean acidification, biodiversity loss, and chemical pollution. Can you tell us a little bit about that?
So the fuels that are discharged and a lot of the black soot that comes out of the stacks can have a significant effect on both water quality and ice melt. So the discharges from the stacks can contribute to ocean acidification, thereby affecting biodiversity. A lot of people are aware that shellfish can lose the toughness of their shells if the water in which they're living becomes more acid, and the calcium in their shells starts to deteriorate as a result. So although I think that climate change is the major thing, all fossil fuel discharges contribute to these other planetary boundaries. And shipping, because it's such a large percentage of the amount of carbon being discharged and the particulates being discharged from the burning of fossil fuels, are certainly part of that problem.
Are you hopeful that the shipping industry can actually help lead the way towards solutions to these environmental issues we're facing?
One of the things that's happening as I get older is I realize that I know a lot of stuff. And one of the reasons that I've been so grateful to the generosity of people who have published some of my work is that I want younger people to understand that there are solutions, that the world is going to be a tough place at mid-century. But if we work on solution-based things, we can make the landing a little bit softer for our children and grandchildren. And really, that's my mission right now, is to get this information to as many people as possible and hopefully engage people, particularly young people, in understanding that there are both ways of feeling hopeful and careers in these efforts to curb climate change and to help us adapt.
If you enjoy the Mongabay newscast, we ask that you please help spread the word by telling a friend. That's the best way to help expand our reach and keep the show growing. For instance, if you know someone who's interested in sustainability or someone who likes the idea of building solutions to things like climate change and other planetary boundaries, this is the perfect show to send them. You and your friend can join the listeners who've downloaded this podcast more than 250,000 times by subscribing to the Mongabay newscast wherever you get your podcasts from. Another way to help is by becoming a monthly sponsor via our Patreon page at patreon.com/Mongabay. We are a nonprofit news outlet, so just $1 or more per month would really help with offsetting production costs and hosting fees. If you're a fan of our audio reports from Nature's Front Line, please head to patreon.com/Mongabay to learn more and support the Mongabay newscast. That's patreon.com/Mongabay. Or you can download our app for Apple and Android devices. Just search either app store for the Mongabay Newscast app to gain fingertip access to new shows and all of our previous episodes. And of course, you can read all of our news and inspiration from Nature's Frontline at mongabay.com. Or if you prefer to keep up with us on social media, follow us at facebook.com/Mongabay or on Twitter and Instagram. Our handle is @Mongabay on both of those platforms. Thanks as always for listening to the Mongabay Newscast. I'm your host, Mike Gurecki, signing off. Talk to you again in 2 weeks.